Hey, good evening, everybody. Once again, coldest day of the season in the Central Plains. So, I don't know how many of you are in the Central Plains. I know we've got kind of a mix here. Give me a second. Let me check my levels and make sure we're all good here. All right, I guess we're ready to roll. So, hello to everybody, Mark and Michael and Sue. I'm sure we'll have some other people showing up shortly. Like I said, we've got the coldest day of the season. The high was 36 at DFW today. We had 33 at Oklahoma City, 27 at Kansas City, and 19 in Denver. And I thought maybe a good thing to cover is exactly how do we get those values? When they say on the Weather Channel or on some website, how do they know where the highs were for the day and what they were? Well, the way we can do that is through the METARs. So this is the METARs from the Aviation Weather Center. I've pulled up the ones for DFW. And at the 0Z forecast, or the 0Z observation right here, you can see they've got these additive groups in the remarks. And one of these is for the current temperature and dew point. So we got 2.2 and negative 10 for temperature and dew point. And then this right here, this is the 6-hour high temperature, 2.2 degrees Celsius. So that's going to be 36 Fahrenheit. And then they also include the low. So you have the low. I don't know what good that is over the past 6 hours, but you definitely want to check that out at 12Z. So we can just pull up one more random one. I know we have viewers in Indianapolis, so I'll put up South Bend. And we can do that likewise. And most stations will report that. And as you can see, some of the lesser ones don't do that. It's mostly the major first order ones that do that. So if we go to Indianapolis and we pull that up, there's the 0Z observation. So their high today was, let's see here, negative 4.4 Celsius. So that's going to be about 25 degrees Fahrenheit. So that's the way you can do it. If you want to get high temperatures and don't want to wait around for the products and bulletins, you can do it that way. Now, another way you can pull up the high temperatures is with the synoptic observations. These are a little harder to get on the internet. If you know where to look, you can find them on university data feeds. This is from a site called Augimet. I guess it's overseas somewhere, but they have all the synoptic observations. And let's see, there's DFW right there. And you can see the observations are all coded. Now, this is what they use when they plot weather maps across the world, around Russia and Asia, Australia, Africa. They use these synoptic observations. So this is the one for DFW that was reported an hour ago. And just to give you a quick rundown, I'm not going to go through all of these, but 72259, that's the WMO number. And then temperature is 2.2, dew point minus 10, pressure 1036.6 millibars. And then their high temperature, same thing as we saw in the METAR, 2.2 with a low of 0.6 degrees above, 0.6 Fahrenheit. So remember, that's a 6-hour low there. Now, at midnight, they do transmit a group that starts with 4 on the METAR observations, and that has the 24-hour high and low. So anyway, that's where some of the highs and lows come from. And it is kind of a cold day, and let's do the thermal and structural review of the weather across the U.S. This is the 7-hour NAM forecast, and we can use this to kind of plot out where the fronts are. And as usual, we're going south of the area of strongest thickness packing. So there's an area of thickness packing. You see another one right there, looking at the blue here. And some of you may be wondering the difference between red and blue. One side is on the 540 line, the other side is not. See, there's 540 right there. And basically that corresponds to where roughly the snow line is. So most of this should be freezing or frozen. Everything to the south should be rain. And that's very dependent on altitude and the thermal profiles. So that's why we go in and use the soundings. So just to complete this, I'm going to bring that all the way down into the Gulf. Looks like a little something going on down here, maybe a little cyclogenesis. That's how the May 13th, 1993 superstorm got started. Almost a very similar picture. And this steamrolled eastward. We had a derecho in Cuba, moved into Florida and produced a number of tornadoes, and then moved up the coast into the northeast U.S. So you definitely have to watch these areas when you have these very strong, deep cold surges heading south. So just to continue this, cold front all the way down in Mexico, and then it kind of recurves north, I think. I'm not too sure what's going on out here. That looks to be pretty certain, and then maybe a warm front through California. So that's kind of what I'm going to go with right there. Then maybe in an occlusion northward there and off the Washington coast, and probably another one out here across the Maritimes. And you can see this is all driven by this very large high pressure area, have a 1050 millibar high centered over Yellowknife. Now when the center of that high is all the way down in the Central Plains, the feed of cold air is just about over. But in this case, it's still well to the north, so we still got quite a bit of cold air left to come southward. I didn't pull up the surface charts. I don't know, I'll probably go ahead and skip that for now, since this kind of shows everything, just a lot of cold air. So what's the weather pattern we have in place? Let's go up to the 300 millibar chart. We haven't really seen this in a while. Actually, I think we did. I think we had one of these up yesterday. But anyway, there's the polar front jet coming from Oregon to Colorado, and then we picked that up through West Virginia and across New York City. And down to the south, you can kind of barely pick out a subtropical jet, and that's going to be a little bit higher, and it's got this anticyclonic curvature. So you see that right there. So there's a little bit of coupling of the jets going on in Tennessee, Kentucky, in that area. And let's see, that's pretty much it right there. And really the other thing that we're watching is up to the north. See that jet coming in off the Arctic ice pack. Now that can be a significant player, because that can, if this whole area turns, if the winds start really picking up through this area and the gradients tighten, that can help channel a lot of Arctic air southward. My phone is going crazy. I don't know if you can hear that. Anyway, let me make sure it's not an emergency or something. Nah, I think it's just a bunch of messages queued up there. All right, so what you see here is a very large low pressure area out there, and this is basically the polar vortex. This is basically just a reflection of all the cold air down at the surface, a lot of deep, cold Arctic air, and you can see some of it extends out over the Gulf of Alaska. So it's pretty obvious that if we kick some of that cold air southward, we're going to kind of deepen the trough in this area. Everything is kind of interlinked, like when you have changes near the surface, that's going to be reflected aloft. And when you have changes aloft, that's going to be reflected at the surface. So let's see, I was going to show you the other thing here. I set up a cross-section from around Brownsville. Wait a second, that's way off to the south. Okay, so subtropical jet off to the south, polar front jet like that. Anyway, I set up this cross-section from here to Nebraska. And we can take a look at that real quickly. You can see that kind of intersects the jet. And I know this diagram's a little hard to read, but maybe I can downscale that just a little bit. Needs a little bit more there. Okay, so we're looking at, this is off the coast. This is about Houston. I'll put H for Houston. Then Oklahoma City, there's O. And then 40, that would be around Topeka. I'll put T for Topeka. So this basically shows the jet core aloft. And this time I labeled the pressure lines with height. So you can see 700 millibars, that's going to be about 10,000 feet. There's 500, which is 18,000, and there's 300, which is 30,000. So you can see a little bit of the polar front jet right through here, and a little bit of the subtropical jet right through here. But really the important thing is the thermal structure of the atmosphere. So let me pull up the product for that. Okay, starting to get a little bit messier, right? So I'm not going to make this too complicated. I'll try to stick with the important stuff. Well, gray is not a good color for isotopes, but anyway, I talked a little bit about this yesterday. The frontal boundaries are where you have the isotopes really packed together. And if you look in this area down here, you can definitely see some packing in here. So we just draw the line on top of that. Do the same thing around here. You can see some packing right through here. And this basically paints out the cold front. Paints out kind of a structural picture of the air mass. So let's see, there's Houston, there's Oklahoma City, and there's Topeka. So we can see in Houston, the Arctic air is probably about maybe 6,000 feet deep. Out over Oklahoma City, it rises to about 14,000. And then over Topeka, it's up there at about 24. And past that, we start getting up into the stratosphere. And I think this right here is going to be the tropopause. So over Texas, that tropopause is up at about 32,000 or so. Now, this is kind of important because when we are looking at the soundings, we like to kind of find these features on those charts. So let's do that real quick. I'm going to pull up the Fort Worth sounding. I'm going to use the UCAR website. They've got a pretty neat sounding page. That's going to be at weather.rap.ucar.edu/upper. And does this correspond to what we saw in the thickness chart? Well, there's the frontal inversion, so we could definitely see where that's coming from. And I think we're topping that out at about 10,000 around Dallas. So there's the top of that polar air. And you can see just above that, there's a little bit of elevated moisture, very saturated air. So if we had a little bit of steep lapse rates above that, like I mentioned yesterday, this would be enough to trigger some elevated thunderstorms. And there have been situations with very shallow Arctic air and very steep lapse rates aloft, where in southwest Oklahoma, back in February of '81, I think, they had sub-freezing weather at the ground with freezing rain and a tornado on the ground at the same time. So you can imagine how crazy that is. But that can happen when you have very shallow Arctic air at the ground. There's a whole different picture going on aloft. So let's go a little bit further north to Norman. And I think we saw that topping out at 14,000. There's 14, and that matches up pretty good. So that's the top of the polar air there. And then we go north to Topeka. No observation. I guess we'll try using Lincoln, Illinois. That's probably going to be the top of the air right there. That's up at about 23,000 or so. So this is kind of a one way you can tie everything together using the cross sections and the soundings. And if you want to try to mess around with some of this, the program is called Wind Grids, and it's free. You can download it, and it's not really for amateurs. It takes some real messing around to get used to. I had to spend... I kind of stopped using this for about 10 years or so and picked it back up recently. And it took me about half a day to kind of get acquainted with everything. There's windweather.org, and basically this is an outgrowth of an internal program that was used at NMC back in the 90s that was called PC Grids. Some of you might have heard of that. All right, so let's see. What else have we got here? Let me go back to the 300 millibar chart. So hopefully this is all starting to make a little bit more sense. Now we're talking about cold weather. Let's take a look at the patterns over the next couple of days at 300 millibars. This is up at 30,000 feet. And you can see that Arctic jet starting to push southward right through here. And we've got a slightly west-northwest flow across the U.S. And you can see over the next several days, we developed this northwesterly flow, which is pretty significant. I'm going to show you a couple of upper air charts from, this one is from 1989. This was one of the coldest temperatures ever recorded in Dallas. They got down to about -6 that day. And a lot of the Central Plains broke records. So if you look at that chart off to the bottom left, look at that. Got a northwest, very strong northwest flow aloft. And that helped dislodge some Arctic air from Alaska and Yukon, and it basically pushed that south into the central U.S. Then I'm going to show you one other chart. This is for February 3rd of 85. Not quite as severe as far as Arctic air, but there was a lot of snow recorded in Texas. So there's that northerly flow, and maybe you see a little bit of difference over the southern U.S. The flow is a little bit more southwesterly across Texas. And I'm going to go back to that 89 chart. You can see there it's more westerly. And then with the 89 situation, or the 85 situation, more southwesterly. So there's a little bit more troughing going on west of Texas, and that's what can help develop low pressure out over Arizona and New Mexico and start building southerly flow over the cold dome and bring in moisture and saturated air, and that's can really get things, snow and freezing rain going on in Texas. Okay, let's see. I'm about ready to head into the forecast, and let me just see if there's any comments or questions. Just reading very quickly, Jeff had access to these OBS. The raw OBS you saw when CompuServe added the NOAA weather wire. Yeah, I had that too back in '83. That was pretty cool. I was plotting a lot of hand-plotted maps there. Let's see here. Okay, not really any questions though. Some comments about the 85 situation. All right, let's get into the forecast here. One of these charts is our forecast, and I think it's that one right there. And I've got to back that up, so run this back to right now. Okay, so I think we're set. So this is the current weather picture, and you can see that little area of cyclogenesis in the Gulf coming together right there. And things look to be a little bit active in Oregon and Northern California, so we've got maybe kind of a Pacific system working through here. There's some strong banding of the thickness gradient. So this is probably a warm front moving northward, getting a little bit of so-called overrunning into Oregon and the Snake River Valley there. So for tomorrow, when we do the web, accidentally clicked the sounding. So if you want to see a sounding of Las Vegas, there you go. Moisture at the surface and warm air aloft and dry air too. So get rid of that there. And of course, thanks to Pivotal Weather for these graphics. I have to give some credit where credit's due. Okay, let me get this all centered. Sorry about that. All right, so when we do the weather tomorrow, there we go. Very similar picture, high pressure across the Mississippi River Valley, 1036 millibar high right there. Still not a whole lot going on in the Gulf. Looks like a lot of cloudy weather and showers there. Looks like our warm front is lifted through Idaho, kind of like that. Tightest gradient's still right there. All right, and that probably connects back to the tail end of that front, maybe through here. So that's probably my guess what's going on there. Okay, then moving forward to our webcast on Saturday, and that's when we have the least number of viewers on this channel. I know some of you will be here, hopefully. But you can see that system out in the Great Basin area moves eastward. And now we're getting pressure falls on Colorado and Nebraska. Maybe starting to get a little bit of a front. I don't know exactly where that is. Could be like that or maybe like this. Some of it is kind of corrupted by this lee side troughing that we have right here. But I think one of these is going to be the warm front, because you can see there's not much thickness gradient through here. So maybe we're going to get kind of a warm up here, I would think, maybe on Saturday. Okay. So we develop a little bit of snow in northern Iowa, and then for Sunday, starting to develop a little bit of a winter storm here. So definite warm front, maybe not that far north, maybe something like that. And on the back end, looks like a bit of a cold front coming into Texas. Is that being driven by a massive high? Well, this is a little bit of a trick question. Take a look up to the north. And remember, you got to be looking at those thickness gradients, those thickness bands. And there's actually two of them. So there's one there, and there's one here. So there's two distinct systems. So this one here is being driven by a lowly, cheap 1017 millibar high over South Dakota. And then this other system, this is being driven by something way up in the Northwest Territories, and that's probably a lot more strong. I can see a 1040 off the corner of the screen, so let's see what happens in Texas. There goes the high pressure area. Cold front's going like that, and yeah, it looks pretty weak, so not much of a cold outbreak. But this thing right here is starting to really get together. And again, this is on Monday morning. And a lot of weather coming together in the Northeast. We're going to cover that a lot, probably in a lot more detail tomorrow. But it does look kind of like a mess there. For Monday's webcast, that little frontal system we had to the south, that's just about out of the picture. And now we're looking at this big system coming southward, 1030 millibar high, and even higher pressure to the north. And you can see the cold core way up here. There you go. You see that that blob right there, that's the core of the Arctic air coming southward. And we run this up to 120 hours and just kind of go quickly. Big norther blowing through Texas right there. So most of the impact is to the southeast on this one. 1038 millibar high across Kansas. And looks like we develop another winter storm system in the northeast. That's off to the edge of the map. There you go. Don't want those of you in the Northeast to feel left out. So there you go. This is 150 hours out, so there could be some error. So we'll keep tabs on that and see what that does. Anyway, so it looks like some more cold air filtering down. Lots of high pressure through much of next week. And then by 192 hours on the 16th, got a major storm developing right here. So did it again. So anyway, this looks even more potent right there. And this one actually looks like it's got more Pacific air working into it too. So that's a pretty strong gradient. It looks like a lot of warm air advection, a lot of overrunning taking place right there. So that's going to really come together here. Wow, that's a pretty cool system there. So Midwest and Great Lakes area for Saturday next week, 17th. We're going to keep our eye on that. Then cold front kind of filters down into Texas on Monday the 19th. Now we're starting to get up to the Christmas break, and you can see for an instant we had some freezing and frozen precipitation in Oklahoma and Dallas on the 20th, very early in the morning. And then that quickly goes away, so probably not much in the way of accumulation. Very strong high pressure. This is a 1050 millibar high. That's very potent, and that's probably going to bring down quite a bit of cold air. And now we're redeveloping some snow, probably going to be snow there in Texas on the 21st. And you can see for an instant right there, look at that, some very strong upslope flow. We talked about this about a week or two ago. When you get upslope flow in West Texas up the Rio Grande, you tend to get a lot of precip back there. And if it's cold air, you're going to get snow there. And then we're up to 360 hours. That's the end of the model run, and that's all crystal ball stuff. So anyway, let's see. That's probably going to do it for me. Let me take a look at the chat real quick. And I think we're about done. I appreciate you all watching, and I hope I'll see you all tomorrow. Thanks.